Hello, Chem family. We are working on dilutions and we have a new equation. M1V1 equals M2V2. Remember, the big M stands for molarity, which is a concentration, which is in moles per liter, and V stands for volume. And volume, we know, can be in liters or milliliters. In this case, it won't matter because units will cancel out, and we will get to that. Let's take a look at number one. It says if I add water to 100 milliliters, so that is a volume of a concentration, and we know it is 0.15 molarity, so that looks like we have a molarity of 0.15, and we have a volume of that concentration, so those two are related, of 100 milliliters. That's why it's M1V1, they're related. And what if we want to have the final volume, it says, be 150 milliliters. So it looks like we're going to be adding about 50 milliliters of water. What will the new molarity be of the diluted solution? Quick question, why will it be diluted? Well, if you go from a volume 1 of 100 and add 50 milliliters to it, adding water is going to dilute it. It won't be as concentrated. So we are going to look for that final molarity. So we can do that real straightforward with the M1V1 equals M2V2 equation. Here we go. M1 has a molarity of 0.15. Volume starts off at 100 mils. Now we want to know what the new molarity is, so we're going to leave that as a variable. But we do know that the new volume of that new concentration will be 150 milliliters. Right? We can multiply everything out. 0.15 times 100 ends up being 15. And we have 150 over here. All right. Now we want to get the molarity by itself. So we are going to divide both sides by 150 so that molarity, M2, ends up being by itself. When we do the math on that, it ends up being 0.1 for the molarity, and that is our concentration. So if you think about it, right, we had a solution, it was 100 milliliters, okay? We then added 50 milliliters of that solvent to now make it a solution that's 150 milliliters. Now we didn't add any new solute, just solvent. So originally, this smaller 100 milliliter volume was 0.15 molarity. But by adding another 50 milliliters, the molarity dropped to just 0.1 molarity. So does that make sense? That as you add water, it became more diluted? And if that's the case, did the molarity go down? Yes, it went from 0.15 to 0.1. So hopefully that makes sense in your head on how that could possibly be, but also that the math helped us solve for that as well. All right, scrolling up to question number 2. It says if I add 25 milliliters to a 125 milliliter solution, and that solution is 0.15 molarity, what will the molarity be of the new diluted solution? So let's think this through. So it sounds like we have a 125 milliliter solution. So let's call that our volume 1. And related to that solution, it has a molarity of 0.15. Now, if we add 25 milliliters to that solution, it now becomes 150 milliliters. All right? Again, why? Because 125 mils, add 25 to it, it becomes 150. All right, easy peasy there. We want to know, now that you added, it's diluted, what is the new concentration? So again, we're solving for the new concentration. Luckily, we know our dilution equation, M1V1 equals M2V2. Let's start plugging in. Our initial M1 is 0.15 molarity. Our initial volume is 125 milliliters. We know our final volume after adding the 25 mils would be 150, so we are just solving for M2. All right, multiply those together and let's see what we get. 0.15 times 125 gives me 18.75. And now that I finish up my equation, I am going to get M2 by itself. So I'm going to divide by 150 to both sides. By doing so, that is going to get me M by itself. And I end up with a small number of 0.125 molarity. Uh-oh, now does that make sense? Well, we started with 0.15 and we went down just a little bit to 0.125. But that does make sense because, again, you started with 100 milliliters and you added 25. So you added more liquid or water to it, whatever. So that means that it was diluted because you added 25 milliliters to it. It still kept the same amount of moles of substance, in this case sodium hydroxide, but because you added water but no more sodium hydroxide, the concentration is lower. So that makes sense why your answer ends up being slightly smaller than the original starting molarity. All right? Hopefully that helps you guys out and gives you a good starting point. Keep up the good work, ChemFam, and we will continue to work on dilutions and different concentrations in class. Take care.